Now my mic's on. Hello and good day. In Algebra CO2, we're going to be talking about how to estimate the root of a non-perfect square. There are a couple terms that we're going to be defining first. Root. What is a root or a radical? Yes.
The result of a number multiplied by itself.
Okay, so the result of squaring something is the product that we get from multiplying something times itself. It's kind of, you're in the ballpark there. But a root is a number that, when multiplied by itself, equals the given expression. A number that, when multiplied by itself, equals the given expression or the given number. So, for example, one that we kind of talked about in the CO1, if I asked you for the root of 36, I'm looking for the number that, when multiplied by itself, gives you 36. And that's why we said the answer to this is 6. Okay? 6 is the root of 36. And there are two different types of roots, when we take square roots of numbers, either perfect squares or non-perfect squares. We talked about these two with rational and irrational numbers. So what's the difference between a perfect square and a non-perfect square? Lucas?
A perfect square can be square rooted, while a non-perfect square can't be.
Say it one more time. There was a whistle in the background.
A perfect square can be square rooted and have like a good stopping number.
Good stop.
A non-perfect square.
Yeah, I'm gonna replace the good stopping number with rational, right? Because that's basically what it is. A perfect square has roots that are rational, meaning they're not a decimal, right? Root 36 is a perfect square because its root being 6, 6 is a rational number. There's no decimal. Give me another example of a perfect square. Gabrielle.
64.
Root of 64, which equals 8. Right? Rational number. Give me another one. Another one. Yeah.
81.
Root of 81, which equals 9. Okay? Perfect square. So a non-perfect square has roots that are going to be irrational. Okay? Roots that are irrational. There are going to be decimals that go on and on and on and on, don't repeat. If I asked you for the square root of 98, let's see. Okay, so if I ask you for the root of 98, there is no whole number that when you multiply it times itself equals 98. So the objective for today is for us to be able to estimate what that value is. Does anyone have an idea here? An estimation of what the value of root 98 is? And those of you holding a calculator with your hand up in the air, that's kind of cheating. That's not estimating, that's calculating. You'll not be able to use a calculator on this section of the test. So being able to do it mentally is kind of where we're headed here. That's what the goal is. You can use a calculator to check your answer, not on the test, but here. But yeah. 9 point something? 9.7? Okay, 9.8, 9.9 perhaps? How did you come up with that? Right. We know that 10 times 10 is 100. So the root of 100 equals 10, which is very close to 98. 98 being a little bit less than root 100, its value is going to be a little bit less than 10. And so we can approximate this to be 9.8, 9.9, 9.7 even. Okay. Yes. Question.
Is the perfect square like Is it the 64? Like when it's like 64 equals 8? Is it the 8 or the 64?
The 64 is the perfect square because that's what we're taking the root of. Yeah, good clarification question. So what we're going to do now is we're going to fill out this table with the perfect squares up through the root of 256. Because in order to be able to estimate these square roots, it's going to be very helpful to know what the perfect squares are. So does everyone have these notes? Can I erase and scroll? We're good? Okay. Pen down, clear ink, scroll down. See how much I'm learning about the order of operations of this board here? There we go. All right. So, perfect square. Let's see. Do I start with? Yeah, no. We'll start with 4. Okay. What is the root of 4? Anyone can just say it. 2. The next one, the root of 9 is 3. Root 16 is root of 25. Root of 36. Root of 49. Root of 64. Root of 81. Root 100. Now it gets fun. What's 11 squared? Evan. The root of 121 is 11. How about 12 squared? 144. 13 squared. Yeah, 12 squared is where your multiplication chart ended when you were like fourth or fifth grade, right? It's a highway that many of you possibly take to get here in the morning. 169. 14 squared. Nope. 196. I appreciate the boldness, though. 15 squared. Yeah. 225. And 16 squared. 256. Okay. It will behoove you to memorize your perfect squares up through 16 squared, up through 256, just because as you get deeper into the maths, you use roots and squaring more and more often. This is nice to have these kind of banked, so you're not always going to the calculator. This being a definition or a key point, this can go on a help sheet. And since you can't use your calculator on your test, I think this might be a helpful addition to said help sheet. Yes?
Does 1 count as perfect square?
Yes, the root of 1 is 1. It is a perfect square, but I didn't include it here. Yeah.
What is the test?
I don't know. Sometime. Yeah, we're on CO2. The unit will end at CO7, so it's probably a couple weeks. Okay, so pick a number that is between 4 and 256. That's not a perfect square. So not in that table there. Yeah, in the back. 210. Okay. So we are going to estimate the root of 210. And our table here is going to help us because what we're going to be looking for, 210 not being a perfect square, what's the next smallest perfect square from 210? Gabrielle. All right, which has a value of what? 14. What's the next largest perfect square? Yeah, Brent. 225, which has a value of 15. So because the root of 210 is between root 196 and root 225, and we know that root 196 is exactly 14 and root 225 is exactly 15, the root of 210 has to be somewhere between here, right? It's going to be a decimal, 14 point something. In the middle here is 14.5. So now we look at 210, and this is a very wise choice here. Is 210 closer to 196 or 225? Because that's going to tell us which side of 14.5 it's on. Is it closer to 14 or closer to 15? As you kind of look at where in between 196 and 225 210 is. Yeah.
Closer
It's closer to 14 by 1, right? It's 14 away from 196. It's 15 away from 225. So really, if you put 14.5, that would be acceptable because it is pretty much right in the middle. I would also accept 14.4. So 14.4, 14.5, either of those would be okay. 14.6 would not be acceptable because that's you saying it's closer to 15, which clearly it's closer to 14. It's on the left side of half. Does that make sense? Yeah? Question?
What if the number was like 212? Would it be closer?
If it would be 212, it'd be closer to the 15 then. So then we're talking 14.6, 14.7, something like that. Okay? Yeah? No, you can just put the estimation there, just the decimal below. Okay? Give me another number that is not a perfect square between 4 and 256. Yes? 50. The square root of 50. Okay? Not a perfect square. So let's look for the next perfect square smaller and the next perfect square bigger. What do we get, Erica?
49.
Root 49, which is 7, and root, yeah, go ahead. 64, which is 8. So because 50 is between those two perfect squares, and we know the value of root 49 is 7, and the value of root 64 is 8, it means that the root of 50 is somewhere between 7 and 8. In the middle would be 7.5, and this one is a little more obvious than the last one. Is 50 closer to 49 or 64? It's closer to 49, okay? So your estimation for this would probably be 7.1, right? It is an estimation, so if you put 7.2, just to be different, that'd be okay, right? But it is 7.1. And of course, really, that's just an estimation. The decimal is an irrational number. It goes on and on and on and on and on, but we are just estimating. Okay? Kind of get the gist of it? All right? When you do the homework down here, and we've got time to go over one or two of them, I do need to see the work. If all you put is your decimal answer, I don't know if your calculator gave you that answer or if you actually thought through it. So this is the work that I need to see here. I need to see you comparing it to the two perfect squares and then narrowing down the value like I did there. Soybean.
Isn't 51 on our homework very similar?
Yes, root 51, the first one there, is going to be a very similar answer to the root of 50. Is that why you picked that one? That was smart if it was. Why? Good. Yeah.
When we check our answer with the calculator, should we put down the answer calculator gives us?
No, when you check your answer, so if you did take root 50 in your calculator, you get 7.1, blah, 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 blah. All you're really looking for, you estimated 7.1. The decimal is about that. I want you to keep the 7.1. Okay. Any from the first row that you'd like to do together? I recommend not picking root 51 because we pretty much already did that one. Yeah?
We'll do the second row.
We'll do one from each. So is there one in the first row that you want to see done?
14.
Sure. Root 14. Root 14, the next smallest perfect square and the next largest perfect square. We look at our table up above. 14 is going to be in between 9 and 16. So 9 and 16, which gives us a value between 3 and 4. Right in the middle is 3.5. But is 14 closer to 9 or closer to 16? 16. So it's going to be on the right side or greater than 3.5. Okay? So you might estimate that to be 3.6, 3.7, 3.8, maybe even 3.9. Okay? Any of those three would be acceptable because, again, it is just an estimation. But you've narrowed it down that far. Bridget.
Can we do like 14.6 or like are we I'm really confused on the 3 and 4.
So what we're doing here, the reason why we made the table the way that we did here was we're trying to take the square root of 14, right? So by writing the root of 9 here, we took the square root of 9 to get 3. We took the square root of 16 to get 4. And so when we take the square root of 14, it's going to be between the 3 and the 4. Yep, kind of like what we have up here. Whoops, that didn't. There we go. Our value is going to be somewhere, because it's between root 9 and root 16, it'll be somewhere between 3 and 4. And that's the decimal that we're trying to estimate. Okay? Yeah.
How do you show like that you checked your answer?
That's kind of on your honor system. Okay? It's just me telling you how you can check it. Whether or not you actually do, well. So, okay. Anyone from the second row that you would like to talk about? Oh, no. Oh, jeez. How far down did I go? Okay, there we go. Second row. Who haven't I heard from yet today that would like to? Yes. Good one. Negative 215. So there is a difference between what you see here, negative root 215, and the root of negative 215. Okay? The position of that negative sign matters. Negative root 215 you can do, because the process is exactly the same to what we've just been doing, only when you're done, your answer is going to be negative. Root of negative 215 with that sign on the inside of the root, this you can't do yet until Algebra 2. Okay? It is mathematically illegal until you learn about something called imaginary numbers, which you'll get to in Algebra 2. Yeah, so like, oof, okay. Do you care enough about it? Can I explain this to you? Do you care enough about? Okay. So okay. Well, if you do, then listen. If you don't, then work on your homework. So if I asked you for the square root of 9, I'm saying what number times itself equals 9, right? And that's why we get 3, because 3 times 3 equals 9. If I ask you for the square root of negative 9, what times itself equals negative 9? Nothing, because 3 times 3 is positive 9. Negative 3 times negative 3 is positive 9. The only way to get negative 9 is 3 times negative 3, but the problem with that is that it's not something times itself. So when mathematicians were presented with this question, they did what anyone would do. They just made the answer up, essentially. They said, well, there really is no solution, but if there was, it would be imaginary. We're imagining the solution is going to be 3, and so we would write that to be 3i. Imaginary is what the I stands for, right? There really isn't a real number that fits that, so we're just going to imagine that it does have an answer. Yeah. That's Algebra 2 stuff there. But anyway, so back to this one here. So if you want to ignore the negative sign for right now, that's totally fine, as long as you remember to add it into your answer when you're all done. So 215, we've got the square root of 196 over here, the square root of 225 over here. We already did one similar to this up above, so we know the answer is somewhere between 14 and 15. The root of 215 is closer to the root of 225, right? So it's going to be closer to 15 than it is to 14. We're probably looking at 14.7, 14.6, 14.7, 14.8 even. But because the original expression was a negative root 215, we can now just add our negative sign back in, negative 14.6, negative 14.7. So the negative sign really doesn't have any impact on the process. You just have to make sure that when you're done, your answer is going to be negative. Okay? That was a longer explanation than you probably were bargaining for, but I have a habit of doing that, so sorry. The question, Soybe, yeah.
Okay, so these 8 columns are on homework.
The 8 that you have here are for homework as well as the real world application down at the bottom here. It says, through your grandparents, you find out your family owns a large plot of land in rural Minnesota. An old map they have shows the plot of land to be a square with an area of 200 square miles. The length and width of the plot have faded because the map is old. Approximately how many miles long and wide is the plot of land? So here's the situation we have here. We've got a square, which is kind of important here, okay? A square that we know has an area of 200. So now you need to think about, okay, what do I know about a square? What do I know about area? What's the objective we're learning today? That might be a hint also, okay? And you want to figure out what the, essentially the length and width or the base and the height of that plot of land. How many miles long, how many miles wide, okay? Well, it's not my job to give away answers. But if I were you, that's what I would do. Okay. Any other questions, comments, concerns, complaints, compliments, congratulations, or criticisms? All right, folks, pressure's now on you. That's how you math.